There are three directions of space which allow us to point out the exact location of everything what exists physically within this space: X, Y, Z. By combining them, we get the 3D environment, the only environment which we can perceive as physical. Hopefully you've learned that it will be better for you if you remain silent. Because I can't perceive nothing what exists in the future or in the past, I don't have anything to support the claims of Albert Einstein, who assumed the physical existence of time beyond the present moment. Come back if you will find any evidence of possible time travel. Good luck. Okay, now it's the time for all the supporters of Standard Model to make your first attempt of defending your precious scientific point of view. Because I still keep some stupid faith in human intelligence, I assume that some of you will tell me that we can measure the time. Everything what is taking place in the dimensional space can be described by its time. You are absolutely correct. Things are taking place in time. Universe becomes constantly real, and it happens all the time since some hypothetical beginning of all creation. However, the time span of all other events is much shorter. Something can be taking place for many days. Some events can happen in the matter of couple hours or years. We absolutely need the time to describe physical existence with all its laws. I think that some part of scientists started just now to smile. You might think that there is still hope for you. Maybe I will allow you to keep some remains of the Standard Model in your pockets to bring you good luck. Sorry, but not this time. I really enjoy to humiliate a defenseless opponent. It gives me a lot of sadistic pleasure. Be sure that before I will finish this course, I will decompose carefully each single aspect of Standard Model. I will rip off all of its deformed limbs and hang them as trophies in front of those who deny the truth. There will be a lot of fun. Let me ask you another simple question. How do we measure the time? We use a physical phenomenon which is taking place in measurable cycles. One day equals to one rotation of a planet which circles around star every single year. This is the ultimate calendar of known universe. No matter on which planet you will live, those constant values could be used to measure the time. Frequency of a cycle is the only scientific way to describe time in physical terms. And there is almost an infinite number of different cycles which keep taking place all the time. Let me show you an example of a random cycle which is taking place in virtual 3D environment. This is a visualization of planetary cycle. Of course, I've made up all the values. Don't expect it to simulate the solar system. In this example, I've created a virtual cycle in which every planet rotates 8 times around its own axis. You can say that this model includes 8 virtual days on a virtual planet. This is all what this visualization shows at this stage. I didn't apply any physical forces, as I want to concentrate only on the cycles in space. Now I will include the orbital cycle of celestial bodies. During the time of 8 planetary days, smaller planet makes 4 full orbital cycles around the central body. You can say that this model includes 4 virtual years. During every orbital cycle, each body makes 2 full rotations. It means that each year on my virtual planet is 2 days long. As I said earlier, this model can be applied to every single planetary or star system. I can modify the frequency of those cycles and turn this into a visualization of Earth's and lunar cycles, or I can turn this into entire solar system. In the universe, small celestial bodies orbit around larger planets. Those planets move around objects which are even bigger. Those objects have as well their own orbital cycles. Moon moves around Earth, which rotates around the Sun, which is orbiting the center of galaxy. Of course, galaxies have as well their own cycles, but let's leave it for now. Let's now include the orbital cycle of this virtual central body. Let's say that it shows the Earth and the Moon which move together around the Sun, which is invisible in this moment. At this time, my model includes the daily cycles, lunar cycles and yearly cycles. I want you to forget about this object for now. Next step is to add the rotation of galaxy. Star in my virtual model rotates together with all the planets around a virtual galaxy center. Because my model is at this moment not big enough to visualize the galactic cycle, I will make the star to move along a straight line. This line shows the distance passed by the star during 4 planetary orbit cycles. Just a second ago, I went through the software crash and the scene which I was working with is gone. Luckily, I've managed to export the model of star system and I can use it in the new project. Good side is that now it works much faster than before. Now, let's look at the same animation from a 2D point of view. As you can see, all the orbits are tilted to the direction in which the central body is moving. This is most likely how it looks in most of star systems. However, I'll make it easier and make the orbits perpendicular to the flow direction. And now the fun begins. Let's hide everything except the celestial bodies and look at their motion in space. Without visible orbits, we can see clearly that the objects don't move in circles anymore. But their motion can be still tracked easily. In order to show you the real motion of those objects, I would have to draw the actual path. Lucky enough, I won't have to draw it point after point, as the software which I use can create spiral as one of the default objects. It saved me a lot of work. It seems as well that it fits perfectly to the frequency of orbital cycles. Check it out. As I said before, in this example each planetary body makes 4 orbital cycles. I've marked in yellow the actual motion path for the Moon. As you can see, it is placed at an angle to the motion path of central planet. Here is the 3D view of the entire animation. From astronomical observations of lunar and planetary cycles in the solar system, we know already that the smaller is the size of an orbit, the bigger is the frequency of orbital cycles. Bodies which move along inner orbits in a planetary star system complete their cycles much faster than bodies placed further from the center. At least this is how the solar system looks like. For the objects located in the Oort cloud, it takes couple thousand years to complete a single orbit. For example, our Moon completes around 12 orbital cycles during a single year on Earth. This is why I will now increase the frequency of lunar cycle in my virtual model. Now it makes 4 cycles for each orbital cycle of the planet. This animation includes 4 planetary cycles, so during this time Moon makes 16 rotations. One more look on the two-dimensional cut view. Of course, the smaller is the orbit, the shorter is the path which a body has to pass during a single cycle. However, it seems that the velocity of orbital motion gets higher the closer to the center the orbit is placed. For now, I've added to the model a second planet which is placed on a smaller orbit and has an orbital frequency which is 2 times higher than the outer body. During this animation, inner planet completes 8 orbital cycles. This is how look the true motion path of the virtual Moon in my model after I made his orbital frequency 4 times higher. And now I increase the frequency to 8 cycles in a single year of the bigger planet. I won't track the motion path of Moon this time, as it gets harder when the frequency grows, but I draw how it looks like more or less. As you probably can see, orbital cycle of the Moon creates another spiral which is wrapped around bigger one, created from the orbital cycle of outer planet. This is the only way to visualize the time. Cycles which are taking place within larger cycles. Frequency of cycles is growing the closer we get to the center of a planetary star system. And this is probably the right moment to start the introduction to the fourth dimension of measurable space. It's time to see my model from a different perspective. Until now, we've watched the motions of celestial bodies from above, but for someone who is located on the surface of a planet, everything looks differently. Size does matter in space. Your perception of environment has almost nothing in common with the world of insects. Beneath your feet exists a realm which you can't even imagine. Although you can peek into the microspace using a magnifier, you won't never be able to see the world from a perspective of a bag. By changing the scale, we change the physical properties of the environment in which mind exists. Difference of size shapes our perception of space. The bigger the difference is, the greater is the distortion of perception. Let's say that you are an ant and you are looking at an elephant, which stands right in front of you. Can you imagine how gigantic would be the beast for you? Think what would happen if he would start to move his front leg and suddenly stomp on the ground couple inches from you. Is it too much for your imagination? Don't worry, there is as well another way. Instead to be an ant, you can remain in your natural size, only change the elephant for Godzilla. It will work just as fine. If you know how to use your imagination properly, you should be able to notice that from your perspective, Godzilla is moving slowly. Of course, in fact it is moving much faster than you are. But to see the actual speed, you would have to come very close to the monster. The closer you get to the beast, the faster it seems to move. From the distance, Godzilla's legs seem to move in slow motion, but when you stand between its feet, you are able to see how fast the movement actually is. But this is just a theory. Question is if it can be proved with science. General theory of everything has to explain each single aspect of the universe, using scientifically valid facts. However, I can't change my own scale, so there is no chance to confirm any of those claims by observation. Luckily, there is much less limits in their digital reality. Although there is no way to scale the point of view, I can play freely with the size of environment. I can as well place the camera everywhere I want. That's all what I need to prove everything what I said before. Look how much your perception depends on the scale and your point of view. You can see here two cycles with the same frequencies. I didn't include any bodies in the upper cycle, but it would be a waste of time, as both cycles match perfectly in the timing. But now, let's put things into perspective. Look at the 2D cut and see how huge is the difference of scale between those cycles. This is the camera which I use as the point of view in the previous animation. It should be a nice point of reference. Okay, time to explain how it affects the apparent flow of time. Both cycles have exactly the same frequency, 8 cycles which take place during the same period of time. Both events seem to have the same apparent velocity of motion. Far in the distance, a giant mutated lizard makes 8 destructive steps towards a defenseless city. Right in front of you, there is a very realistic model of Godzilla. Toy seems to work nicely, as during the same time it makes as well 8 mechanical steps. What makes the difference between those cycles is the distance which was passed after 8 steps of the Godzilla toy and the real monster far ahead. With which of its steps, giant monster is passing a distance which is many times bigger than the distance completed after all 8 cycles of the toy. Difference of scale is in such case equalized by the distance in physical space. But because the larger object has to pass greater distance in the same number of cycles as the smaller body, velocity of motion has to be much higher in the bigger cycle. Difference between both velocities should be visible better when we will place both cycles next to each other. I've decided to move the smaller cycle inside the bigger one, just like in the case of orbital cycles in planetary systems. But all what I said until now wasn't anything new for the science. The real bomb comes in this moment. As you can see, the larger body moves much faster than the smaller one, and this is not what I wanted to see. Couple minutes ago, I've told you that the bigger the cycle gets, the smaller is its apparent velocity for smaller cycles. But in this animation, large body moves much faster than the smaller one. So maybe I was wrong? I can bet that many of you would be delighted if my claims would turn out to be incorrect. Sadly, not this time. I have already most of the answers, so better prepare, as the rotten world of science will tremble in a second or two. You see, problem is that this software uses a completely virtual measurement of time. Length of animation is described by the number of frames, 600 in this case. In this virtual environment, it is the only objective way to measure the time. However, flow of time depends on the subjective perception of a mind. Sadly, this software doesn't include any kind of tool which will simulate the brain. Distortions of the frequency rate won't affect the length of animation. To observe time dilation, I need to measure the time. But what to do if there are no units of time in this environment? Didn't I tell you recently how to define the time in space? I will simply use the units which I defined somewhere in the beginning of my explanation. Let's say that those 4 cycles will become my unit of time. 4 months in 1 year. This is the way in which I will measure the time. Look out, as I used the same length to describe the distance in physical space. This is something different. In the difference to the Godzilla example, this measurement can't be used as objective value, as it depends on variable numbers. Time is not a dimension, but the rate of everything what takes place in the environment. And now, let's see what will happen with this rate if I compare it with the smaller cycle. And here it is, just as I predicted. During the time of 1 virtual year, smaller body makes 32 cycles, what causes a significant increase of its apparent velocity. Now you can start digging the grave for standard model, but I think that better to burn it alive. Of course, the distortion of time flow should work as well in the other way. And it does. In this example, time is defined by 8 orbital cycles of the smaller body. During this time, large object makes only 1 cycle. From the micro perspective, bigger planet is moving very slow. Let's compare now the velocities of bodies in all of the cycles. I've had to slightly modify the model. Now 8 orbital cycles define 1 year for all the bodies in every virtual system. Cycle in the bottom of this view shows the objective frequency of both cycles. Smaller cycle is a scaled model of the bigger one. In the middle is the frequency of cycles measured using the time on the big planet. Cycle on top is based on the frequency of smaller body. I think that this example proves nicely how much the apparent flow of time is affected by the difference of scale in physical space. And this is how I came to the first conclusion of general theory of everything. Infinite scale is the fourth and last of physical dimensions in space. 11-dimensional multiverse is just as scientific as flat Earth theory. I'm sure that some of you will tell right now that all those planetary cycles don't have any actual meaning on Earth, where we have the global time and atomic clocks. How our perception of time can be affected by some other cycles. This concept of time dilation is probably completely virtual, right? Well, not really. This model can be applied to every possible situation, which includes the apparent flow of time affected by scale. I base it on motions of celestial bodies in space, but I can use it as well to describe the environment of Earth. For example, let's imagine that we are suddenly shrink to the size of a cockroach. To make it more funny, let's assume that we have two clocks with us. One is digital and one is analog. Let's add as well someone who remained in his natural size and keeps watching us from above. The plan is to measure the flow of time from my own micro perspective and the perspective of someone with normal size. For now, let's assume that the cycle of bigger planet on the bottom represents the frequency of analog clocks in the macro environment. 8 hours, but it doesn't matter. I was shrinked together with both clocks. According to the analog one, the flow of time didn't change at all. The frequency of his mechanism was shrinked together with me. Okay, I admit that it was a stupid idea to tell you about the digital clock. In fact, I have no idea how scaling would affect the frequencies of a microchip. Let's say it simply exploded. Anyway, let's try to guess how the microscale affected your perception of environment. The rate of apparent time flow would be scaled together with me, so it will remain normal in my perspective. Only by comparing the measurements of apparent time, I would be able to guess that something's wrong with all the clocks on Earth, except my own watch, which seems to work nicely. I won't even talk about all the details which I would be able to see in the micro scale, but generally I would start to resonate with a completely new frequency band. On the other hand, from the macro perspective, my voice would become squeaky and my movements would appear to be faster. After a couple of weeks, I would be probably dead. If I wouldn't be eaten by some killer insects from microscopic hell, I would probably die as an old man due to the increased rate of apparent time. And now probably most of you will try to grow bigger. Good luck. There is still one more aspect of physical space which I have to discuss in order to proceed further, deeper and closer in the creation of an unified model of universe. I've told you a couple minutes ago about the infinite scale. Is it really infinite? Or maybe there's some physical limit for zooming the dimensional space in and out? Let me answer this question with an example of a random cycle, which can be seen in microscale. Now let's zoom out. As you can see, from a distance, wave pattern turned into a solid line. Of course, the software which I'm using is not a simulator of universe, so the zoom factor reached right now its limit. But allow me to make the first assumption of my theory. Is it a theory at all? I can't find too many things which I still have to prove. In this case, I assume that in the scale dimension there is a point for each cycle when the frequency becomes so high that it turns into solid physical existence. Of course, it works as well in the other way. Zooming into solid matter will at some point turn it into a wave. Maybe some of you know already how I will use this assumption in next movies. I hope that you've liked my new form of education, because something tells me that this is what I want to do until I won't cover everything what the unified theory of universe will include. And believe me, there is still a lot to cover. Today I just touched it for the first time, and probably caused global disaster in the world of science. All I did for now was to describe the environment in which I will place together all the pieces of universe. At least the part which describes physics of plasma is almost completed. But there is still a long way ahead of me until I will reach space weather. But before I finish, I want to confirm everything what I said in this movie with couple visual evidences. As some of you probably noticed already, in my model there is not much to argue with. But if you still treat my explanations as some virtual and paraphysical mumbo-jumbo, then look at those examples of time dilation in the dimensional scale.